Good morning, sir. This is fourth class Decadet test, and this is my video for the midterm exam. First, here is our ship's course, speed, observation time interval, and the distance. Our own ship's course is 10 degrees with a speed of 20 knots, and the observation time interval 5 minutes. The distance 1.6 nautical. Be able to solve for the distance. The formula distance equal to speed multiplied to time. And the speed is 20 knots multiplied to time, which is 5 minutes. But first, we must make this 5 minutes into hours. To make this 5 minutes into hours, we must use the formula 5 minutes divided by 2, 60 minutes over 1 hour. So we will cancel minutes, 20 knots equal to 0.08 hours. Now we will be able to solve for a distance which is 20 knots or 20 nautical miles per hour multiplied to 0.08 hours. So we will cancel the hour so that there will be only nautical miles left. The answer will be 25, 1.6 nautical. Next up is we will plot our target's observation. So, with a time of 1300 hours and the range of 8 nautical miles, the bearing is 140 degrees. And since our observation time interval is 5 minutes, so we will take the other vessel's range and bearing with a time of 1305 hours, the range of 6 nautical miles and 135 degrees bearing. Now we will proceed in plotting the target's observation. The first observation with a time of 1300 and 140 degrees, the distance from 8 degrees. But we must take into place that our ship's course is 10 degrees. Instead of plotting 140 degrees, we will add 10 because our ship's course is 10 degrees. The 8 nautical miles is located right here. And the second observation with 135 degrees, 6 nautical miles. After we were able to plot our target's observation, we will now be able to make the relative motion line. To be able to determine our closest point of approach, we must make a perpendicular line and extend it to the center of our maneuvering point. Now, with the use of a compass divider, we'll now be able to determine the distance, closest point of approach. The first point must be the center of the maneuvering board. And another point is the seatbelt. Next, we'll drag it to our scale, which is 2:1. Now, we will get our CPA of 1.8 1.8 nautical miles. Now that we were now able to determine the closest point of approach, which is 1.8 nautical miles, we will now proceed in solving for our TCPA. So in solving for the TCPA, or the time closest point of approach, first we must look for the time required. So the formula for time required is equal to distance over relative speed multiplied to 60. But before you'll be able to solve for the time required, we must first solve the relative speed. So the formula for relative speed is equal to distance over time. So the distance used is the difference between your first observation, the first observation, and the range of your second observation. So the range of our first observation is 8 nautical miles, must be subtracted to 6 nautical miles. So our distance will be 2 nautical miles. Our time is the difference between the first time that you used in your first observation and the second observation, which is 5 minutes. Again, we will convert 5 minutes into hours. 5 minutes divided by 60 minutes over 1 hour. We cancel minutes. We will get an answer of 0.08 hours. So now we'll proceed. 2 nautical miles divided by 5 minutes, or 0.08 hours. So now we will now be able to solve for relative speed. And our relative speed is 25 nautical miles per hour. To determine the distance for our time required, we will be using a compass divider. The first point, the last observation, and the other point to your closest point of approach. Afterwards, we will drag this to our scale, which is 2:1. And we will get the distance of 5.8 nautical miles. Now, we will now be able to solve for our time required. So the distance, which is 5.8 nautical miles. And the relative speed, which we were able to solve a while ago, is equal to 25 nautical miles per multiplied to 60. And the answer is 13.92. And we round it off to 14. So with the time required, we could now solve for our time closest point of approach. First, we must add the time of our last observation, which is 13:05 hours, added to 14 minutes. We will now be able to get our time of closest point of approach, which is equal to 1319 hours. Thank you, sir. That's it for my video.